Hello friends, I am Krishna Kanjani from LG Institute of Engineering and Technology. Welcome to the online lecture series on kinematics and theory of machine. In this session, we will learn about velocity and acceleration analysis. Okay, in previous session, we have discussed the instantaneous center method and how we can identify various instantaneous centers. So in this session, we will learn most IMP theory, that is Aronhold-Kennedy's theorem. This theorem is also termed as a three-center in-line theorem. Okay, so now let's start this session with Aronhold-Kennedy's theorem. So this theorem states that if three bodies are moving relative to each other and they have three instantaneous centers, then these three instantaneous centers must lie in a straight line. Okay, how we can consider this? So let's consider three bodies, that is link number A, link number B and link number C. Okay, so let's consider these three links have relative motion with respect to each other. Okay, so in that case, how many instantaneous center will be there? So we can find out number of instantaneous center by equation, that is capital N, number of instantaneous center is equal to small n into n minus 1 by 2, where small n is equal to number of links. Okay, so over here we will have three number of links. Okay, so we can say 3 into 3 minus 1 by 2, so that will give us 3. So in this mechanism we can say that it will have three instantaneous centers. Okay, so now we have to locate these three instantaneous centers. So first we will locate for link number B. So now as link B is connected with link number A with this pin joint, so we can say that over here we will get instantaneous center IAB or IBA. Similarly, link number C is connected with A. So we can say over here with this pin joint we can locate another instantaneous center, that is ICA or IAC. Okay, so we can simply identify in this way that link A, B and C, if we consider it is moving, then IAB will be located with respect to this point B and ICAC will be located with respect to point C. Okay, so this A with respect to this A, this B and C will give us two instantaneous centers, that is IAB and IAC. Okay, now this will be permanent as they are making pin joints. Okay, now let's find out instantaneous center of point B with respect to point C. Okay, so now with respect to point C we can locate that it will be at their pin joint IBC over here like this. Okay, so now if we consider instantaneous center IBC over here at their pin joint position, then we can say that if you want to find out the direction of velocity of link B, then we have basic rule that any link will have a velocity in the direction perpendicular to its line of action. But we can say with respect to this line P or this link P, we can say it will be having velocity in perpendicular direction. So in direction like this VBC, if we consider point B, or we can say if we consider IBC point on link B. Okay, similarly we have to consider this IBC point on link C also. Okay, so if we consider IBC point on link C, then now over here we will observe that link C is in this position, so there its velocity will be perpendicular to line C. So now we will have velocity of BC with respect to point C will be in this direction. So in this way we can say that IBC point will have a velocity in two different directions, VBC over this in left hand side or VBC in this right hand side. So over here we can observe that any one point have velocity in two different directions. Is it possible? No, it is never possible. So over here we can say that if you want to locate this point IBC, then this point must lie in the line of joining line AB and IAC. So it must lie on this line in horizontal plus x direction or minus x direction or at any intermediate point on this line. but the basic condition is that it must lie on this horizontal direction. Okay, so that is all about this Aronhold-Kennedy's theorem. It states that if three bodies move relative to each other, then if they have three instantaneous centers, and these three centers must lie on a straight line. If they are not lying on a straight line, then either we can say that these three bodies will not have relative motion between them. Okay, so as we have referred in this diagram, if we have considered over here three links, so we can observe that this is forming a structure, because in this case we can never have relative motion of B and C. Okay, it will always have a fixed position. Okay, so in this way we can prove that Aronhold theorem says that three instantaneous centers of bodies which are moving relative to each other must lie on a straight line. Okay, clear? Okay, now let's learn the method of locating instantaneous centers so that we can solve numericals. Okay, so let's consider learn few steps that we have to follow while solving the numericals. Okay, so let's consider a 4-bar chain mechanism. Okay, so if you consider a 4-bar chain mechanism having link number 1, link number 2, link number 3 and link number 4 are connected in such a way like this. Okay, if you consider this mechanism, there's 4-bar mechanism having 4 links, that is 1, 2, 3 and 4, which are in this position. Okay, so the first step that we have to follow is we have to determine that how many number of instantaneous center this mechanism will have. Okay, so we can give this we can use this formula that capital N, that is number of instantaneous center, is equal to small n into n minus 1 by 2, where small n is equal to number of links. So over here, if we will put number of link is equal to 4, so over here we have to put small n is equal to 4, and over here small n minus 1, that is 4 minus 1, that is 3. So over here we will get 4 into 3, that is 12 by 2, that is equal to 6. So over here we can say that in this 4-bar chain mechanism we will have 6 number of instantaneous centers. Okay, step number 2, we have to make list that which are these 6 instantaneous centers. Okay, so to identify that, we have to make one table in which first row that will be your links. So link number 1, 2, 3 and 4. Then instantaneous centers that we have to locate. Okay, so over here if we consider for link number 1, then link number 1 will be connected to 2, so that's why it will give 1, 2. If we consider with respect to 3, then it will give 1, 3, and similarly with respect to 4 it will give 1, 4. Okay, so that is the number of instantaneous center for link number 1. Now similarly for link number 2, if you want to identify, then link number 2 will make pair with link number 1, but 2, 1 is already mentioned as 1, 2. Okay, 2, 1 or 1, 2 both are same. Okay, so over here we can say that 1, 2. Now similarly 2 will connect with 3, so that's why 2, 3. 2 will connected with 4, that's why 2, 4. Okay, now next one, link number 3. Again it is connected with 1 and 2, and that is obtained with, we have 1, 3 and 2, 3. Now link number 3 is connected with 4, so that's why it will give us 3, 4. Okay, and 4 is connected with 1, 2, 3, and that we have already mentioned 1, 4, 2, 4 and 3, 4. So over here in this way we can identify that in this mechanism we have to locate these 6 instantaneous centers one by one. Okay, so first we will identify number of instantaneous center, then we have to make list that which are that 6 instantaneous center. Then step number 3, we will locate fixed instantaneous center by simply inspection. Over here we can say that if we consider link number 1 as your fixed link, then over here link 1, 2, that is your pin joint and fixation, and over here link 1, 4, that is again your pin joint and fixation. So 1, 2 and 1, 4 both are fixed instantaneous center that can be directly sketched with simple inspection method. Okay, now second method second points, that is permanent instantaneous centers. Now permanent means again at a pin joint. So over here if we consider 2 and 3 is joining over here, so I2 3, and similarly 3 and 4 connected, that is I3 4. So I2 3 and I3 4, these both are permanent instantaneous centers that also we can simply put by inspection method. Okay, now next one, remaining two, that is neither fixed nor permanent instantaneous center, and that we have to locate by Kennedy's theorem. And to implement this Kennedy's theorem, we will use one circle diagram method. Okay, so over here we will consider that in this mechanism we will have number of links. So we will sketch one object which is having 4 sides. So we can say it is a square or rectangle. So we will first we will sketch one rectangle over here. Okay, so let's consider over here. So as we have sketched 4 lines which are representing various link number 1, 2, 3 and 4. Okay, now we have to draw one circle which is joining these 4 points. Okay, this circle will give us the different other instantaneous centers. Okay, so how we will find the remaining 2? So in this diagram, in this case, we have to identify that first which 4 centers we have obtained. So over here, let's first locate that which 4 centers we have obtained. So first one is I12. So over here I12 that we have located. So in this table we can make circle on I12. Similarly we have located I14. Okay, so 1 I12, I14, 2, 3 and 3, 4. Okay, so we will locate I12, I14, I23 and I34. Now the remaining 2, which are remaining 2, 4 and 1, 3. Okay, so now to obtain 2, 4, we have to connect these 2 and 4 point on our circle. Okay, so in our circle diagram we will connect this 2 point and 4 point. Okay, so by connecting these 2, 4 point, we will observe over here. So if you want to connect this 2, 4, okay, so that will give you 2, 4 line. So how we can sketch this 2, 4 line? So that to obtain this 2, 4 line, we have 2 triangles. First one that is connecting 2, 3 point, and second one is 1 and 4. Okay, so we have to connect these 2 and 3 and 1 and 4. Okay, so by extending 2, 3 and 1, 4 line, so if we extend this 2, 3 and 1, 4 line, then it will give us the remaining I24 point. And similarly we can locate for I13, or we can say by connecting another 2 circles. Okay, so in this way, by using this circle method, we can sketch I13 and I24. Okay, in this sketch you can observe that for link number 1, 2, 3 and 4 over here, if you observe this diagram, then first we have located these 4 points I14, 34, 23 and 12. That is by simple inspection method, by simply inspecting the diagram of this mechanism. Okay, and that is connected with your 1, 2, that you have connected these 2 points 1, 2, then your 2, 3 point, then 3, 4 point, and there then 1, 4. Okay, so in this way 1, 2, 2, 3, 3, 4 and your 1, 2 point, that will give us the whole mechanism. So 1, 2, 2, 3, 3, 4 and 1, 4, that is your whole perimeter of this square. Okay, now we have to locate remaining 2, that is your I13 and another one. If you locate over here 1, 2, that you have located 1, 2, 1, 4, then 2, 3 and 3, 4, and then remaining one is 2, 4. Okay, so first we will exercise for I13. So over here in this diagram, if you want to connect this I13, then you have to connect 2 lines. That is your link number 1. This one is your I12 and this one is your I23. Okay, so if you extend this 1, 2 and 2, 3 line over here 1, 2 and 2, 3 line. So if you have to extend this 1, 2 and 2, 3 line. Okay, so this will be your line number 1. Now another way to make this 1 3 connection, okay, to connect this 1 3 line, another combination is your 1 4, I 1 4, and second one is I 3 4. Okay, so now if you extend I 1 4 and 3 4, okay, so 1 4 and 3 4 by extending this line, okay, so now this intersection will give us I 1 3. Okay, so in this way we can locate the remaining neither fixed nor permanent instantaneous center by this circle diagram. Okay, similarly we can proceed for the second one, that is for the remaining, that is 2 4. Okay, so now for this 2 4 line, let's connect this 2 4 line. Okay, so now to make this 2 4 connection, we have to connect two instantaneous center, that is I 2 3 and 3 4 in a one line. So let's consider 2 3 and 3 4, I 2 3 and I 3 4. So over here I 2 3 over here and I 3 4 is this. Okay, so you have to extend this line I 2 3 and 3 4. Second one, that is your I 1 4 and I 3 4. Okay, so 1 4 and 1 4 and okay, over here sorry, I 1 4 and I 1 2. Okay, so 1 4 and 1 2. So by extending these two lines or by joining these two green lines, you can observe that you will get I 2. Okay, so by this circle method we can locate neither fixed nor permanent instantaneous center in any of the mechanism. Okay, so with this help by using this method we can solve numericals of instantaneous center. Okay, so you have to learn this 6 steps properly, and if you will follow these 6 steps, then you can solve numericals of this chapter. Okay, we will solve one numerical in our next session. Thank you.